Thank you. So I'm going to be talking about the application of machine learning to predict severe maternal morbidity. So we all know that maternal mortality is a very big problem in sub-Saharan African countries. I mean, the maternal mortality in Uganda is at 336 deaths per 100,000 live births, whereas according to the SDG 3.1 target, they want to reduce the maternal mortality to 70 maternal deaths per 100,000 live births by 2030. So we are clearly very, very far away from that goal. Now, for many, many years, and still at the moment currently, maternal mortality is still being used as a major indicator of maternal health at national level. However, even though there are many women dying, dying during childbirth, it still doesn't mean that we have enough data to accurately predict maternal death or to accurately estimate the predictors of maternal death. So maternal death is a rare event. Even if you go to a hospital and try to look at data over 1 year, 2 years, you will find a few hundred deaths, right? So additionally, maternal death is just one of the outcome of morbidity during pregnancy. For every woman that dies, 20 to 30 women actually suffer from severe maternal morbidity. Some studies even report 50 women per one maternal death actually suffer from a morbidity. Now, maternal morbidity can have lasting effects on a woman's physical, mental, sexual health, ability to participate in society, body image, and social economic status. Maternal morbidity does not only affect the mothers, it has quite severe negative impacts on the fetus also. So new studies actually now suggest that instead of focusing on maternal mortality, we should look at maternal morbidity as a means of averting or as a means of reducing mortality, because maternal morbidity, there is more data to look at. And with much more data, you can make better predictive models. So instead of trying to avert the death, we can intervene before the pregnant woman actually gets severely sick, and we prevent the morbidity, and hence we can prevent death. Now, sub-Saharan Africa has the highest burden of SMM. So the most common morbidities include hemorrhage, sepsis, and hypertensive disorders. This include preeclampsia and eclampsia. So of course, there has been studies that have looked at both maternal mortality and maternal morbidity, but of course, we still have some gaps. These include use of small data sets. You will find quite a few studies done on mortality, but because mortality is a rare event, people are forced to use small data sets. Sometimes people use survey data, but there is recall bias, few variables in survey data, and there are many other studies that have been done in developed countries, including studies that have used machine learning methods to predict morbidity and mortality. However, the findings cannot be generalized to African settings. Next is that one of the drawbacks, or one of the other gaps in literature, is that studies usually use a traditional analysis method. I mean, if you even right now, if you look at studies that look at predictors of both mortality and morbidity, most studies use logistic regression. A lot of African studies have been, studies in Africa have been done in Nigeria, in Kenya, in Uganda, even on obstructed labor, on sepsis, on hemorrhage, but people mostly use logistic regression. This is traditional analysis method, and yes or no. So people mostly look at mortality or near miss. Now, the problem with looking at only one analysis model is that you do not look at this. You do not look at this issue, the variance bias issue, the trade-off between variance and bias. If you do not look at that, if you do not test your model on a test data set, you end up you could potentially end up with a model that has very low predictive power. You could overfit your model, and your model fails to work on a novel data set, like a newer data set. So I just like to talk briefly about the bias variance trade-off, because it's quite a focus in the machine learning area. So if you look at the first graph here, so we see that it looks like somehow there's a U shape in this scatter plot, but just a straight line has been fit through. So what is happening here is that there's a high bias but low variance. So this model could potentially work on novel data sets, but as we can see, the predictions are so far off. I mean, the actual points are so far from the line. So if you want to predict, your predictions will be so wrong because you'll predict just along the line. On the other hand, you could end up overfitting. Overfitting is you draw your line so close to all of the points, such that if there's a small change, let's say in a novel data set, the point is here, this model will fail, yeah, because it has been overfit. So what happens is that with machine learning actually balances the bias variance trade-off. All right, so why machine learning and why not just traditional models? It should be noted that, of course, we still look at traditional models like regression analysis. It's not like we forget about them. They have to be included because sometimes you might find that in some data sets or in some problems, traditional analysis methods actually might work better. But so why machine learning then? So of course, now we have seen that the prevalence of maternal morbidity is so high. So we need to put into place some predictive models that will predict these morbidities in real time, like when a woman goes for her first ANC visit. Her data is gotten, fit into the model, and the midwives or the doctors can know, okay, this is going to be like a serious case. We need to monitor this woman closely, yeah? Now, so many recent studies have found machine learning processes to be an invaluable asset in prediction of diseases, including maternal morbidity. And these machine learning models usually have more accurate prediction. Now, at the moment, we are now becoming more aware about the importance of data in all countries, right? So even if you look at the National Referral Hospital in Uganda, they have quite extensive data on the women who actually come in for ANC and for delivery. So they have so many variables, like more than 50, 60 variables, right? So this, if you look at it, it's somehow it has the V for volume, that is a characteristic of big data. So machine learning techniques actually work quite well with big data. So yeah, and we have, of course, many variables. The only challenge is that this data, I can say for sure in Ugandan settings, has not been what do you say? It's still pen and paper. It is not electronic. It's not like an electronic maternal health record system. So of course we have issues of missing data, incomplete data. Some variables are not being recorded at all. But in the future, we are hoping that a few years down the line, we shall have more comprehensive, more complete data. Now, on the other hand, we have statistical software like Stata, R, Python that have really eased fitting ML models. I mean, with R, it's so easy to fit a model nowadays. Just download, just install the package that you need, like a cart package or the random forest package, and the codes are so easily available online. There's so much R documentation, and the R community is so big. So you cannot fail to get the codes for any particular problem that you need, right? So it's so easy to fit models nowadays. And you can get codes for the confusion matrix, for the RS seekers, or even cross-validation, whatever you need. So you can easily split your data set into training, testing data, fit your model on the training data, test it on the testing data, see if it is working, otherwise use cross-validation. Or you can modify your models. For instance, you can play around with the K in your KNN, you can play around with how big you want your tree to grow, and so on and so forth. And the tuning parameter in the neural networks, all that is so easy to work out. Yeah, it's not like it doesn't require somebody to sit and just experiment manually, right? I was just working with the decision tree, and the codes are so easy to you can just copy paste it from a data camp website, or there's so many websites. Now, so I looked at, of course, there are so many studies that have been done using machine learning on maternal morbidities. However, there are very few there are very few studies that actually look at machine learning and maternal mortality or maternal morbidities in African settings, especially like East African settings. I could not find anything on obstructed labor, unfortunately. However, if you look at studies done in, for instance, China, US, I found one study that was done in Nigeria. And it's this one, modeling the determinants of maternal mortality, a comparative study of logistic regression, and ANN, artificial neural network model. It was done in Nigeria. They got data from a health facility in Ibadan, and they found that actually the neural network model was a better fit, like it gave better predictions than the logistic regression model. Similar to other studies, like there's prediction of maternal hemorrhage, they found that the XG boost performed better than random forest logistic regression and SVM.
You have 3 minutes.
I'm actually done. I had to.
Thank you. This is exciting. Yeah.
Yeah. I had to rush a bit. As you can see, I had made quite a big presentation, but I was worried that I won't be able to present everything. So yeah, and more studies like novel electronic health records applied for prediction of preeclampsia, machine learning algorithms. They also found the XG boost had better performance than the other models. And then there was one study that looked at studies that were available online and got all their data sets, and they did like a meta-analysis. So they used 7 data sets for predicting of sepsis, and they actually used they used deep learning, and they found that the machine learning approach was more accurate in predicting sepsis that exists than existing sepsis scoring systems. So you will find that there are already in place like predictive models, but I mean, the world is changing, and you will see all the time, like new machine learning models are coming up, new models are coming up. And if you explore, you will find that this one fits my data better, this one fits my data better, you know? And we can easily avert, we can easily like predict like maternal morbidities compared to like before. Now, for myself, I'm doing a study on 3 morbidities. Those are obstructed labor, eclampsia, and PPH, that's postpartum hemorrhage. So I'm also looking at machine learning models. I got like a big data set, and I'm also looking at machine learning models. And just from, because my study has become quite big, and it was unanticipated, but it has become quite big. However, just simply when I looked at logistic regression to predict the 3 morbidities separately versus trees, decision trees, and random forest, just a simple analysis, and it took me like it takes like around 10 minutes to do that, and it showed me immediately that actually the random forest performed better than the other models. So yeah, I think I can end at that. And of course, this is like it is interesting. We can do a lot more in the countries that we are in. Get big data, get a lot of data, use machine learning models, and see which one performs better, rather than just doing a logistic regression and says, okay, these are the predictors of maternal morbidity. Thank you so much for giving me this opportunity, and happy Women's Day to all the women here.
Thank you, and happy Women's Day to you as well. This was very informative, this was insightful, inspiring, and it was interesting. Thank you so much, Shaheen, for your presentation and for presenting it at the time that we allowed you to. Thank you, and over to you, Philomena.
Thank you, Shaheen, for your presentation, and thank you, Millicent, for moderating the session as well. So I'll hand it over to you, Mahadia, for you to do the closing remarks and close off the conference.
Thank you so much, Philomena, and thank you so much, Shaheen, and also Gloria. We thank you all for staying a bit, I mean, not a bit late, staying late. We'll just check if there's any question in the chat before we do the closing remark. Philomena, do we have any question in the chat for Philomena? I mean, for Gloriana or Shaheen?
Sorry, I was muted. There's a question for Shaheen. I don't know the objectives of your study, but what will you do to overcome the challenge of paper-written data?
All right, so that's actually a good question. So when I first wrote my proposal and then collected data, it took us so long to collect data, and then of course the problem with what pen and paper like records is missing data, right? I mean, like these are like government facilities. You'll find like just a few midwives, around like maybe 3 or 4 midwives getting like 100 women a month. You know, this is a facility that get like 2 to 3,000 women each month. So imagine how many women are coming for ANC every day. They can simply not record everything, no matter how hard they try, you know. So like we will have missing data, and that is a problem which we will find everywhere. Like any administrative data you use, you will find missing data. Now, so I actually wanted to present that, but because of time, I could not. But so the first thing that I looked at in my study was missing data in administrative records. I did a presentation, I did a seminar, and yeah. So I looked at different methods of imputing data. I looked at I looked at random forest. I looked at mice, that's multiple imputation using chained equations. I used that mode imputation. I looked at 5 methods altogether. And then I compared which one was the best. And I also showed that, see, if you don't try and impute missing data, if you just use list-wise deletion or whole case, complete case analysis, you end up losing a lot of data. Now, at the moment, since we have not yet migrated to like electronic systems, we are forced to use what we have. And that data is still so good and so important. So yeah, my advice would be to anybody using administrative data is, if you're collecting 10,000 records and if you see like 5,000 of them have at least one missing point, so that is like case-wise missingness, right? Don't use list-wise deletion. Don't just go straight into analysis. No, first try and impute the missing values. After that, you do your regression. And many studies have shown, I mean, many of the pioneers of imputation methods have actually shown that even up to 90% of missing data, when imputed using principled techniques, still yield good results.
Thank you, Shaheen, for the answer. Follow-up question, is the paper-written data being converted to digital data?
Actually, at the moment at the hospital I'm working at, they're currently in the process of that. But when I talk about electronic system, I don't mean converting the paper records to electronic, because garbage in, garbage out, right? What was there will still reflect in the electronic system. What I'm meaning, in the future, we are hoping, so this is actually policy implication that came up from my study, and we've written a policy brief and hope to take it further. What we mean is that we want, like, imagine if the midwives had tablets in their hands, right? And if they had the questionnaire, if they had like the maternal form in it, okay? So imagine if there's a question like height, like we found height was not being recorded. So imagine if there's a question like height and somebody puts in the height, okay? So there would be like, let's say somebody puts in 300 centimeters. So the tab would say, no, you have done something wrong, okay? Put in the right height. So already we have done data validation, right? And then let's say if somebody wants to skip height, the form can say, no, you have to fill in. Like, think of a Google form, right? The form will say, no, you have to fill in the height, okay? You're not allowed to skip. So that is what we mean by an electronic system, like fully electronic. So yeah, they are converting, like they're putting the data that was in paper into the computers, but what is in the computers will still be in the paper. In fact, me as personally, I would actually trust the paper records more than what has been uploaded, because I mean imagine the people who have been taking the old records and putting them into the electronic system. I feel they would make mistakes or leave some things out, so I'd rather use what is originally there. Thank you.
Oh, great. Well understood, Shaheen. Thank you, Leila, for the questions. I'll hand it over to you, Mahadia.
So there's just one question. I'll just read it out because of time. So did you experience skip patterns, and how do you handle skip patterns in the survey form, because they also add the missing value in the data? So yeah, that's the question that I have for Shaheen.
Is that during data collection? Because in ODK, for instance, the programmer who programs ODK, like let's say question 103B would be a follow-up to question 103A. Let's say if the answer to question 103A is no, then question 103B will simply not be asked. And it skips to like 104. I don't know if I got the question.
I think you got the question right, because I think the question, it was more on handling the skip patterns in the questionnaire. So yeah, so clearly if
Okay, you have, sorry. Yeah, you have to be careful about that, because if you leave it as missing, then, okay, if you leave it as missing like blank, when you do imputation, there's chances that that will be given like an answer that was not supposed to be there. So maybe perhaps give it like a category like 0 if it's not supposed to be there. Then the other categories, you can give them other numerical values.
I think that is right. Yeah, I agree with you, and thank you for that, Shaheen.